Welcome. That's the right song. Welcome. Today we're going to go a little deeper into computer science. We're not going to talk a lot about the way that we program. We're going to talk a lot about the way the program operates. So let's start. Today we're going to talk about function call stacks and stack frames as well as headers and a couple of other things. To understand how C performs function calls, we first need to consider a data structure, a collection of related data items known as a stack. Think of a stack as analogous to a pile of dishes. When a dish is placed on the pile, it's normally placed at the top, referring to as pushing the dish onto the stack. Similarly, when a dish is removed from the pile, it's normally removed from the top, referred to as popping the dish off the stack. Now, obviously, you don't want to pop a dish because it'll break, but needless to say, that is the analogy. Stacks are known for last in, first out, LIFO. The last item pushed on the stack is the first item popped from the stack. An important mechanism for computer science students to understand is the function call stack, which is sometimes called the program execution stack. The data structure working behind the scenes supports the function call and return mechanism. It also supports the creation, maintenance, and destruction of each called function's local variables. Now, we've talked about creation, we've kind of talked about maintenance, but we haven't spoken about destruction. And in a lot of situations, it is very important that you destroy your variables or the program destroys the variables that you've used, or destroy the arrays that you've used, or destroy the function calls that you've used, because if it doesn't, you can run into a lot of overflow problems, stack overflow problems, buffer overflow problems in your code execution. Each function eventually must return control to the function that called it. So the main function is the function that's called when the program is run. And when the main ends, the whole entire program ends. Well, we can call functions in the main, and if you have not seen that video, go back and look at the video about functions, function definitions, and more, and you'll learn more about how that actually works. Each time a function calls another function, an entry is pushed into the stack. We've talked about this. This entry, called a stack frame, contains the return address that the called function needs in order to return to the calling function. So the way it works, and I'll pull up the code so you can kind of see it. The main runs. The main is the main function. It runs. And then we called a function called max. And like I said, if you don't remember what we did here, go back to the functions and function declarations video and you'll see how we wrote this. The max function is actually being called from the PCH class. We wrote it into the PCH class. We included the PCH class into the console application, and then we called the PCH class. When max is executed by the program, what essentially happens is the program pushes a stack frame above the program, above max, to say, hey, when you are finished, you need to go back to this line in the function main. That's what that means. That's called a stack frame. If the called function returns instead of calling another function before returning, the stack frame for the function call is popped, and the control transfers to the return address in the popped stack frame, meaning that the function, the root function, which is our main, if let's say we called another function inside of max, let's say we wanted to do something else. Well, the stack frame that tells max to go back to the main will then be passed on to that new function. And then the function that's executed in the max, or whatever the case may be, will go back to the main when it is complete. Each called function always finds the information it needs to return to its caller at the top of the call stack. Call stacking is basically where the functions are being called. And if a function makes a call to another function, a stack frame for the new function call is simply pushed onto the call stack, meaning the function will have to go back to the main because that's the stack frame that was stacked onto the last call of the function. So in this case, the main then calls max, okay? A stack frame, a call stack frame, is then placed in the stack frames, okay? You don't see this is all in the background. And it pretty much says, max, when you're done, you need to go back to main. Well, let's say max calls another function inside of it. Let's say it wants the time, and it says, okay, I want to get the time, and it goes and calls another function. Well, function time will go back to max, or it'll go back to the main. The call stack for the main is still prevalent there in the stack. All that happens is a new call stack is made, and the stack frame for max is put above the stack frame for the main. And what happens is that, just imagine there's a call here. Let's say we said, we put another function here and said int value. right? We call the value, the function value. It doesn't exist. I know. I'm just putting it there. Let's say, so in this case, the main executed. Then it called max. It goes to max, and then a call stack or a stack frame is put into the call stack to say, when you're finished max, you need to go back to the main. But then max runs and calls the function value. Well, then another stack frame is then put into the call stack above the main that says, hey, value, when you're finished, you need to go back to the max. And then when that is executed, LIFO kicks in, last in, first out. That call stack or that stack frame is then removed. And then the next stack frame that's in place says, okay, max, when you're done, you need to go back to main. That's the way that works. I know it sounds a little confusing, but it really does make a lot of sense when you see it in real time. The stack frames have another important responsibility. Most functions have automatic variables, parameters, and some or all of their local variables. Automatic variables need to exist while a function is executing. They need to remain active if the function makes calls to other functions. But when a called function returns to its caller, the called function's automatic variables need to go away. Now, parameters, as we created in our function here, are automatic they're automatic variables for the function. They need to be filled, or the function will never run, and you'll get runtime, or you'll get compile errors. Those automatic variables only exist within the body of the max, or within the body of this function. When this function is finished, and the call stack says, okay, what's the next stack frame? Go back to the main? Cool. X and Y will be destroyed. They will no longer exist, because the context of the function we called changed. We went back to the main. And the main doesn't really care about these functions, or the main doesn't care about the variables that are contained within max. All the main cares about is what max is returning to it, or if max isn't returning anything to it. Return is not required, and I'm not going to go into that right now, but just know that you don't always have to return a value. The called function stack frame is a perfect place to reserve the memory for automatic variables. That stack frame exists only as long as the function is active. When that function returns and no longer needs its local automatic variables, its stack frame is popped or removed from the top of the call stack, and those local automatic variables are no longer known to the program because the program destroys them until the next time that function is called. And I can call max as many times as I want to. But every time max ends, when that stack frame removes itself from the call stack, those variables that exist within the max no longer exist. They go away. And the only thing that comes back is whatever's returned. Of course, the amount of memory in a computer is finite, so only a certain amount of memory can be used to store stack frames on a function call stack. If more function calls occur than can have their stack frame stored on the function call stack, a fatal error, known as a stack overflow, or the blue screen of death, occurs. So, and then it goes into detail about how the call stacks work, but we've just talked about this, so we're just going to keep on going. Keep on going. Here's a representation of how the main executes the application, but we keep going. The main and then executes the integer or the function square. You can see how that's all going. If you want to go over this yourself, you can. This is not important. We've already talked about it. It is important. We already talked about it. We talked about this. We talked about that. Talked about this. Headers. Okay, this is really easy. Not even going to waste a whole lot of time. This is a header. Basically, what a header does is it includes other classes in your in the class that you're writing in, and it inherits. This is a very interesting word I'm going to use right now. It inherits the functions from those classes. So remember, we created a class called PCH. In this class, we created the function intMax. In order for intMax to be accessible to console application 1, we have to include the PCH.h, not C, this is a header, in the console application 1 class. Once we do that, Max is accessible. If I removed this, okay, which we've already done once, and I saved it, and then I tried to build this to check to see if there's any errors, it'll tell me, hey, what are you even talking about? There's a function in console application 1, but we don't know where it comes from. Could it possibly be in PCH? The answer is yes, it is, and so I'm going to put PCH back. I'm going to save this, and that error should go away. Value. There is no value. I'm going to get rid of that. Oops. Oh, please, keyboard. There we go. Yeesh. All right, now it should be fine. There we go. Succeeded. Too easy. And that's a header. Blah, blah. Let's keep going. There are other headers that you can use or other classes that are contained within the C library. These are just a few of them. The ones that are important to you are float and math. So the math header allows you to call math functions that are already created and available to you in the C library. So if I wanted to call the math function square root, I don't have to create that. I don't have to write square root in there and do the validation for square root and all that jazz. I don't have to write my own square root function. It already exists. All I have to say is include math.h. And let's say I wanted the square root of something. So int square root equals math dot, is that incorrect? Math. I think, let me see if I'm doing this correctly. Yes. I keep forgetting I don't have to call it. So in this case, I don't have to say math. I just say square root. There's the function. And then I can say, oh, give me a number, blah, 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 square root of 49. And then I'm probably, yep, there we go, done. Let's comment this out really fast. And let's test this bad boy. Puts val. I mean, that's all I really care about. Let's see if it works. Yeah, I didn't think that was going to work. Okay. Then I'll just do tried and true printf square root equals, and then we'll say you are a, please, there we go. You are an integer. Val should be fine. Run. The answer should be 7, by the way. Stop. I'm sorry. I didn't stop it from debugging the last time. Moving a little too fast. Okay. Because it's, oh, there it is, square root 7. It was still open. Wow, what was going on? Square root equals 7. It worked. So what did I do there? I added the math header, the math class, to my program, and now I can use math functions in here. I don't have to write square root. I can just say squirt. So that being said, there's other ones in here. You can use the math. Just look up math.h, and it'll tell you all the library functions. You can look them up. CodeCogs has the libraries. I mean, the libraries are all over the place. I literally just picked a mathematical library out of the top of my head. But if I scroll this over here, you can see, you know, a cosine, a sine, a tangent 2, ceiling, cosine. It's just all of them. Square root's just one of them. You can do exponents. You can do whatever. They already exist. You can just take that math.header, dump it in there, and bing, bada, boom, you're cooking with gasoline. So let's keep it moving. Time is also a big one. I've been using string. So, in many programming languages, there are 2 ways to pass arguments. You can pass an argument by a value, and you can pass an argument by a reference. When arguments are passed by a value, a copy of the argument's value is made and passed to the called function. We spoke about this in the last video referring to functions. If you did not watch it, please go back and watch it. I go into detail about how arguments are passed to parameters, which are actually just variables, automatic variables that exist within the function. Pass by value should be used whenever the called function does not need to modify the value of the caller's original variable. This prevents the accidental side effects that so greatly hinder the development of correct and reliable software, blah, 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 blah. Keep going. So, pass by reference should be used only with trusted called functions that need to modify the original variable. In C, all arguments are passed by value. You don't want to pass anything by reference. So, and that's it. Like I said, this is an in-depth analysis into computer science with respect to C. We're talking about how it actually is working. We're not really talking about how you can manipulate the language. If this was a video that you liked, please hit the like button at the bottom. And if you really want to see more videos like this, subscribe. Either way, you have a good one. Ciao.